Hi, I'm Aston Turner. Welcome to my demo video. I'm on my study net. I'm just downloading the files I've submitted so I can demonstrate my project. So this is my final report. The title is Development of a Maze Game Engine using Java. The aims of this project were to essentially develop a 2D maze game that can be played on a desktop platform. I'll demonstrate the artifact as shown in this zip folder, and I will do so in the order. I'll try my best to do so in the order as shown in the table of contents in the report. I'll be starting with chapter 4, the code structure, and then I'll be going through all the design and development chapters up till chapter 8, gameplay, UI and graphics, and after that is testing. So I'll go from chapters 4 to 8. So I've just extracted this folder that I've downloaded, and I'll just quickly show you all the classes here I've created throughout the project. There's an assets folder which contains all the images I've created and the animation frames of the dog, which is the player, and the keys. So this is made in NetBeans, so I'll just open up NetBeans 8.2, which I used throughout the project, and I will open this project up from the downloads folder. Open project, downloads folder. Yep, here it is. So starting with chapter 4 with the code structure, this was the first class I began with, and I created a game loop in this class under the run method. The run method overrides the runnable interface so it can be run as a thread, and so multiple threads can be running at once. It invokes, you can see here it invokes render method, and then here it invokes the update method. So this is a continuous render and update cycle. It keeps running as long as the game state is running. So this is just an initial render here, and then it's updated and rendered again throughout this while loop. So originally all the render methods were in this class, but they were refactored into their own renderer class here, and all the methods in here are related to rendering, so they render the maze, they render movement of the maze, and so on. I'm just going to get straight into the game now. So this is a main class where the game starts, and the parameters needed. I'm just going to start the game straight up by pressing this button. So this is the default configuration you'll be greeted with when you first run in the project. It's a fixed size. This will run from GUI classes, and this is the view you're shown. The next step in the project was the development of a tile map so I could build a maze on it. So I'm going to get straight into that, but to do so I need to provide a zoomed out appearance of a game so it's easier to demonstrate how the tile map works. So I just need to change some variables to make that possible. So I'll reduce the size of each individual tile. I'll put the tile border on even though it's broken. It did work originally but it became broken when I updated the graphics, and I'll change the variable sizes of the window to make it bigger. So now you can see a lot more. So you can see here, even though the toggleable border I put on isn't working completely correctly, you can roughly see where each individual tile is. I've done this as demonstrated in chapter 5 of the report to achieve this layout, and later in chapter 6 I generated a maze as shown here using my implementation of the recursive backtracker algorithm. So the recursive backtracker algorithm characteristics means that it has no cycles present, and there is a single path between any passage tile and any other passage tile in the maze as shown here. And if I close the game and rerun it, it will generate a new maze every time because it invokes the maze generate method. As seen, it's always a new maze. So I met the aim of generating random mazes in the project. So I'm just going to change the variables back to the default now. So that was 100, and then in here I'll change a maze for width and height of a window. So it's back to the default values now. So the next thing I'm going to demonstrate is the game functionality, which came in chapter 7 of the report. So first thing I'm going to demonstrate is the player movement. So if I hold left, it moves left. If I hold right, it moves right. And if I hold up and down, the player moves up and down. I'm just going to quickly turn off that toggleable border, just because it shouldn't be on. Okay, it's off now. So as demonstrated is movement with the arrow keys. Next collision, as you can see, I can freely pass through the passage tiles, but I can't. If I try to go into the walls, I'm not able to do so. Also, you can see the exit is demonstrated here for the door. I've collected enough keys as shown in the UI at the top. I have collected 3 keys out of the 2 required on level 1. If I go for this door, I can progress to the next level, like so. The door is always randomized, the exit is always randomizing, but it's an algorithm checks that it's far enough from a player, so it never spawns close enough to a player, as shown in the report. Next, the player placement is always randomized also. If I run the game, you can see the player spawned there. Now the player spawned here. It's always randomized. But the exit tile, the important thing is the exit tile is always far enough away from the player that it doesn't make the game too easy. So next in chapter 8, I'll demonstrate the levels that I implemented. So I completed level 1 with the 24 seconds here, as shown in the level selection menu. If I replay level 1 from here, you can see these levels a lot. If I replay level 1, I can try to beat this time and demonstrate the high score I implemented. So I think I've beat this. If I go back to the main menu, you can see it's now overwritten with 5.11 seconds. And I can play level 2 because I've completed level 1. So next I'm just going to discuss these keys that I implemented also in chapter 8. So each one, as shown in the top right here, I need 2 keys to open the exit on this level. So the keys, the maze always begins with twice the amount of keys required. So on level 1, you need 2 keys, so there'll be 4 keys. And out of the 4 keys, they all start disappearing one by one in a random sequence. And it will take 5 seconds each. So this one will disappear soon because it's blinking. Now this one's going to disappear. If I don't collect enough keys, as you can see, I've failed the level because I needed 2 keys and there wasn't 2 keys left in the maze because they'd disappeared. So that's a failed level. I can retry the level or return to a menu, which I'm going to do here. I'm just going to show you now completed level, just to show you what happens if I complete a level. So that was a dead end there, so it's going to be a long one. Okay, that's probably one of the longest ones I've done, but that's completed level. As you can see, I can progress to level 3 now. The maze grows in size slightly, as shown in the method in this class called increase level. I'll just show you. As you can see, the rows and columns are increased by 2 when the level count is increased by 1 every time. So I just failed the level there because I've run out of time. All the keys disappeared. The next thing I'm going to show is the save and loading functionality. There's a lot of methods that come with this, but essentially it comes down to a text file which is located in the assets folder. Just quickly show you that. So here it is, level date.txt. you'll see it aligns with the data shown in this level selection screen, 5.11, 20.5 shown here. If I click reset, it actually overwrites the level data with this kind of default data set. So if I click reset, that's reset. If I complete a level and close the game off and rerun the game, it's actually saved. I'll just demonstrate that now. As you can see, I'll close it off completely, rerun the game, open level selection, the data's still there. Lastly is the graphics animation, as you may have seen. This is run off the animation frames, also in the assets folder in here. So when I hold the left key for the dog, the left sets, the right set, and up and down sets are cycled through. The same with the spinning keys you may have seen, and I created the blinking animation like this just by skipping a frame every odd frame, so only the even frames are shown. I think that's about everything. Just to provide a conclusion to this demo video, I think I completed all the aims and objectives I set out to achieve, as explained in the discussion and evaluation chapter of this report. It's a 2D maze game. It generates random mazes. I created it all in Java, and all the game functionality is present, as you can see, with some user interface features. I look forward to seeing what questions you have for me in response to this video, and I think that's it. So goodbye.